What if I told you this is not just a mirror? This is a real-time air quality monitoring station in a picture frame. It's like magic. When the device is off, it's a mirror. But when powered on, it transforms into this futuristic air quality dashboard. Inside this sleek frame, I've packed some serious tech. It's powered by an ESP32 and features a scrolling air quality graph, real-time temperature, humidity and CO2 readings, all hidden behind this one-way mirror. Now the question is, does it even work and react to its surroundings? So let's put this thing on the test and see what happens when I, for example, blow this candle. Whoa, you can instantly see the air quality graph went to the roof, indicating that the air quality is very poor. Also, there is a tree indicating the oxygen levels, which is pretty cool. The changing color from green to purple indicates dropping oxygen level, and you must open your windows for ventilation. Now let's take it outside and test it in the fresh air. And just like that, it detects improvement in the air quality and oxygen level. This isn't just a project, it's a real-time health monitor for your environment. Now let's dive into it and see what parts we need to make this. First of all, we have this particulate matter sensor, which is used to detect tiny harmful air particles that can enter the bloodstream. It took me a while to find this sensor out because PM sensors are not cheap. Luckily, I stumbled upon this cheap one because it's a replacement part for the Xiaomi purifier. Next, we have these two sensors. One is to measure the temperature and humidity, and other is to measure the TVOC and CO2 levels in the air. To display everything on the screen, I will be using this 480 by 320 TFT display. It can be controlled via SPI protocol, which makes programming and wiring very easy compared to that messy parallel interface. Other than that, I decided to use this 7-segment display to display time, because why not, it's a dashboard. To make sure that the time stays the same when you unplug the power, it is important to use an RTC, also known as real-time clock, to keep the time. Now the particulate matter sensor has its own fan to circulate air, but it expels the air out and won't circulate inside. Since the temperature, humidity and CO2 sensors will be in a very tight space and won't be exposed to the ambient air, I thought it would be a good idea to add a fan to circulate air inside. This will keep the readings correct and real time, compared to those Chinese temperature displays which will take ages to track the temperature. The next thing I ordered was a picture frame to put everything inside from AliExpress. You can see it has a bit of depth, and they are apparently called shadow boxes. Also, I bought this one-way reflective film to stick on the underside of the glass, which is actually plastic. Those cheeky Chinese manufacturers. Obviously they wouldn't use glass because it will break and all that stuff in the shipment. Next, I prepared a mixture of soap and water to make the film application process easy, which is exactly what they use to apply the wraps and protective films on cars. Spray the liquid on the surface and also on the sheet. Then carefully place the sheet onto the surface and use a card or hard plastic to remove the liquid without getting any bubbles. Once done, trim off the edges with a box cutter and you now have a one-way mirror. It's a pretty cool effect because you can see the reflection and it's opaque at the same time. Now the frame is ready, let's secure the LCD and 7-segment display in place. For that, you could use this black piece of card paper to increase deflection and cut space for the display and secure them with a hot glue. But luckily, I have access to a 3D printer. So I designed and printed a faceplate that can take both the TFT screen and the 7-segment display. I've made these grooves for the display to sit against and using a bit of glue to secure them in place. And now we have a neat looking front plate that we can slide into the frame. Next, I had to think about how to mount the fan and the sensor. For this, I again designed and 3D printed these covers to go with the fan and the sensor. Next, using a Dremel, which I stole from my brother's toolbox, I made these holes for the PM sensor as well as for the fan. Once that's done, I can then put the covers on and use some M3 screws to secure the PM sensor in place. Then we can move on to the fan cover and repeat the same. But this time I'm using some washers as well, because after all it's a thin sheet of MDF. And finishing off with securing the fan using a generous amount of glue. Perfect. And here I thought, why not put some more glue, and end up doing this. Okay, so moving on, it's time to make the circuit, which is the most fun part, at least for me. Well, you can see this project involves a lot of sensors, microcontrollers, displays and stuff. So I could have said that this part of the video is sponsored by XYZ company. But I assure you, I thoroughly checked my email and it turns out I have to solder everything by myself. It took me 4 hours to build this PCB, but for you it's going to be a 30 seconds build montage. Oh yes, the ancient art of soldering, also known as trying not to burn your fingers. The clock is ticking. Every connection must be perfect. One slip and the whole plan could fail. These tiny parts think they can escape, but I've got my soldering iron and a steady-ish hand. One wrong move, well, let's not talk about the resistor incident from last week. Sometimes it feels like the board has a mind of its own, daring me to mess up. Anyway, by the end of this, the circuit will either work or make a very expensive paperweight, which I obviously don't want. Okay, that was deep. Before this masterpiece disappears in magic smoke after we power it up, I would like to get you on board with a plan. So we have an ESP32, which is a controller, and it will have some software to tell it what to do. Alongside, we have a bunch of sensors connected like CO2, temperature, humidity and PM10. Also a screen and a 7-segment display. And not to forget the real-time clock, also known as RTC. These sensors will communicate with the ESP32 via different communication protocols, which is in my case either I2C, SPI or UART. The software will control all the sensors and displays, which will act as slaves and only give out information/reading when they will be asked by the controller, which will then push the data onto the screen. Sounds easy. Now one idea is to make it portable and have batteries inside. But since it's more like a weather station and won't be moved around much, so I decided to keep things simple and use this USB-C breakout board to get 5V output. Now some of the sensors also require 3.3V. Since we already have a 3.3V regulator in the ESP32, we can leverage that to power the sensors. Now some of you might notice a mysterious looking thing. This is actually a level shifter, which I know is required after destroying multiple ESP32s. You see, the RTC requires 5V to work, therefore it communicates on 5V as well on its data and clock lines. Guess the ESP32 GPIO pins are only 3.3V tolerant, and obviously it's not gonna like 5V. That's why we need this level shifter to convert 5V logic signal from the RTC to 3.3V. Happy ESP! Okay, enough of the theory, coming back to the build. Once again, I designed another mount for the USB-C breakout board and also to hold a push button, whose purpose I will explain you in a minute. But before that, let's use some super glue and secure this circuit board with standoffs. I know, it looks pretty neat. I'm excited. Now we can solder the button and the USB-C breakout board and connect to the main header onto the PCB. Afterwards, plugging the sensor cable followed by the fan connector. Once that's done, we can slide in the front plate in the frame. In goes the display and the 7-segment followed by a one-way mirror. To connect the LCD and 7-segment display, I thought it's a good idea to use pin headers, so the back cover can be easily detached if needed. Now before closing everything up, I want to show you something. The unseen work behind making this project. Look at all this code for this microcontroller. It took me 6 months to write this code. And don't worry, I will explain it to you line by line. I've broken this down into multiple tabs, so it's slightly easy to understand, and I've linked everything to this main file. We are not here for your boring explanation. You don't even know how to write software. I saw you copying code from ChatGPT. What are you talking about? I wrote this all by myself. It took me 6 months. Go away. Well, my future me says explaining software is boring. But if you're interested, I've linked all the files down in the description. After programming the ESP32, it's basically all done, and we can close it all up. Awesome. So yeah, what started as a plain picture frame is now secretly monitoring the air I breathe. I mean, most mirrors just tell you you're losing hair, but this one goes, open a window before you suffocate yourself. And honestly, I love that. It's not just a project that ends up on a shelf. I actually use it every day. Cooking? Graph spikes. Open the window. Everything calms down. It's like a quiet health monitor just chilling on the desk. But here's the fun part. I don't want to stop here. Imagine a bigger version, a smart mirror that shows your calendar, weather, maybe even reminds you to drink water and tells you when your air quality is trash. Or maybe link it with smart devices to open the window automatically. That'd be cool for sure. What do you think? Let me know in the comments. I seriously read all of them. If you want to try this build yourself, I've left all the code, wiring and STL files linked down in the description. Alright guys, thanks for hanging out in the Artix Lab. Don't forget to hit like, subscribe, and most importantly, go get some fresh air. And I'll see you in the next one.